Welcome, fellow cloud architects, SREs, and platform engineers. Today, we're diving deep into something that's just absolute bedrock for any high-performing engineering work. We're breaking down the structural necessity of blameless postmortems in modern cloud platforms. Now, in this explainer, we're not just talking about some boring meeting you're forced to have after something breaks, right? We're talking about a core architectural principle. We're going to look at the psychological safety you actually need to make this work in the real world. Think about it. How do we take those highly stressful, totally chaotic outages and turn them into our absolute most valuable engineering assets? How do we really scale our operational maturity? Well, let's jump right in and find out. All right, so here's our architectural blueprint for today. First up, we'll look at the reality of cloud incidents. Then, why blame destroys reliability. After that, the postmortem learning lifecycle. Fourth, conducting root cause analysis. Fifth, driving continuous system improvement. And finally, number 6, building a blameless culture. Okay, let's kick things off with Section 1, the reality of cloud incidents, complexity and inevitability. So let's establish our baseline reality right out of the gate here. Modern cloud platforms, they're incredibly, sometimes staggeringly complex. I mean, we're dealing with hundreds of microservices, globally distributed databases, asynchronous event queues, unpredictable third-party APIs, the whole shebang. Because of the sheer complexity, even for the absolute best engineering teams on the planet, incidents are just completely inevitable. Think about it. Think about the last time a seemingly benign DNS misconfiguration brought down an entire availability zone, or a cascading failure just tore through your message brokers. It's really not a matter of if a system will fail, but when. And as architects, we have to design our culture around this inevitability just as carefully as we design our infrastructure. When those alarms go off and we're looking at a high-impact issue, the organizations that improve the fastest use a really specific anatomy of a postmortem. They use it to turn failures directly into engineering improvements. Because, site reliability engineering isn't just about putting out the fire. It's about systematically documenting it, so it literally never burns the house down the exact same way twice. Let's ground this with a practical metric. Say you get a sudden 5.2% error rate spike that causes a 33-minute partial outage. Now, in a mature SRE environment, that isn't fundamentally viewed as a sign of engineering failure. Instead, it's seen as an incredible opportunity to learn systematically. When you see a metric like that flash red on your monitoring dashboard, obviously the immediate goal is to mitigate the impact. You might fail over to a backup region, restart a service, or quickly roll back a recent deployment. But the secondary, and honestly the arguably more important long-term goal, is to extract every single ounce of data and context from that spike. We've got to move beyond just mitigation and get into deep understanding, like what actually happened. Was that 5.2% error rate caused by a latency spike and a downstream dependency? Was it a thundering herd problem after a cache invalidation? Or maybe a noisy neighbor on the underlying compute node was just exhausting your CPU resources? We absolutely have to extract that context so it never surprises us the exact same way again. Moving right along to Section 2, why blame destroys reliability, the danger of fear. Now, here's the kicker. Extracting that deep context and actually learning from that error rate, it's completely impossible if our immediate reaction is pointing fingers. Seriously, if the very first question someone asks on a high-severity outage bridge is, "Who broke it?" you've already lost the reliability battle. And that brings us to the formal definition of a blameless postmortem. It's a structured review conducted after an incident where the goal is explicitly not to identify who made a mistake. Let me repeat that because it's absolutely crucial. We are not looking for a human scapegoat. Instead, the entire goal of this exercise is to identify system weaknesses, process gaps, and missing safeguards. We're actively looking for where the architecture failed the engineer, not where the engineer failed the architecture. But doing this effectively requires incredibly high organizational maturity. It requires genuine psychological safety. Think about it. If an engineer is absolutely terrified of losing their job over a misconfigured YAML file, they are simply never going to be honest in this review. And the result? Your organization remains totally blind to its own vulnerabilities. As engineering leaders, we face a stark choice here: fear or transparency. On one side, you have the blame game, which creates an environment totally rooted in fear. And when engineers fear punishment, it drastically reduces transparency across the entire organization. Information gets hidden, timelines get intentionally obfuscated to protect individuals, and the real systemic root causes just get swept under the rug. You learn absolutely nothing. But on the flip side, a blameless culture yields shared learning, fundamentally better systems, and much faster iteration. Let's look at a classic example. Imagine an engineer who accidentally drops a critical production database table. Oh boy, right? If they fear being fired, they're going to hide it. They'll try to fix it silently in a panic, and your mean time to recovery, your MTTR, just absolutely skyrockets while your customers suffer. But in a blameless culture, that exact same engineer immediately jumps into Slack and says, hey, I just ran this script in to drop the database. The team immediately rallies, restores the backup, and the outage is resolved in minutes. Then, the postmortem focuses entirely on fixing the IAM permissions and the deployment guardrails that allowed a single untested script to bypass safety checks in the first place. Which brings us to Section 3, the postmortem learning lifecycle, from alert to resilience. So how do we actually operationalize this philosophy into a concrete, repeatable workflow? Because we don't just want a good attitude, right? We need a highly reliable framework. To get there, we embark on a strict learning lifecycle. It starts right at the incident, exactly when customer impact is genuinely felt. From there, we journey into analysis, where we objectively gather up all the metrics, the logs, the hard facts. Next, we push into root cause discovery, peeling back all the complex layers of the failure. Then we land on concrete action items designed to permanently address those underlying root causes. And finally, we push those items all the way through to actual system improvement. Keep in mind, this isn't just some chronological checklist, it's a dynamic feedback loop. This entire pipeline is literally what converts raw operational pain into hardened system resilience. It's how we ensure the exact same class of incident doesn't happen again. The very first pillar of this life cycle is the incident review, and specifically establishing an exact chronology of events. We've got to map out a precise, factual timeline. Let's look back at our 33-minute incident progression as an example. So at 0912, the impact begins as database latency quietly spikes. At 0918, the CPU usage alert finally fires for the API layer. At 0924, active triage reveals a massive memory leak, which is resulting in out-of-memory kills in a critical sidecar container. Down at 0931, the container orchestration system is instructed to forcefully restart the pods as a rapid mitigation step. And finally, at 0945, the system health normalizes and the queue drains. Documenting what happened and exactly when, without any judgment or emotional language whatsoever, is the absolute foundation of everything that follows. Bottom line, you simply cannot fix a distributed systems failure that you cannot accurately reconstruct. Let's dive into Section 4, conducting root cause analysis beyond the symptoms. Once we know the specific timeline and the exact customer impact, meaning how our end users were actually affected in the real world, we transition to looking way beyond the immediate symptoms. As cloud architects, our root cause analysis has to focus aggressively on technical factors, process gaps, system weaknesses, and contributing organizational factors. But here's the thing, an RCA is completely useless if it stops at mere discovery. It has to translate directly into actionable engineering tasks. If your RCA reveals a glaring process gap, your corresponding action item must be a concrete process enhancement. Crucially, let's say your system weakness was an exhausted database connection pool that cascaded into a full outage. Your action item is never, tell developers to be more careful with their queries. No way. The action item is implement automated connection throttling, rate limiting, and circuit breakers in the middleware. Every single root cause must have a corresponding, trackable action item that relies on automation, not human vigilance. All right, on to Section 5, driving continuous system improvement, proactive SRE. This entire methodology is what bridges that massive gap from reactive firefighting to proactive, continuous reliability engineering. We aren't just putting out fires anymore, we are actively fireproofing the building. When done correctly, this SRE perspective ensures that out of all these painful outages, organizations consistently deliver tangible real-world results. We're talking common outcomes like better monitoring to catch that latency degradation much sooner next time around, or improved runbooks so your on-call responders know exactly which dashboards to look at 3 a.m. We see additional automation to completely remove human toil, stronger chaos testing in your CI/CD pipelines, and just much better overall architecture documentation. But hey, a quick word of caution for the engineering managers out there, tracking is absolutely critical here. If you write these brilliant, insightful postmortems, but the action items just sit in a Jira backlog forever, slowly gathering dust, this entire culture fails. The ultimate goal is relentless, continuous improvement actually shipped to production. Finally, we arrive at Section 6, building a blameless culture. Fix systems, not people. Ultimately, adopting all of these SRE practices isn't just about your technical architecture. It is heavily, heavily dependent on your cultural architecture. Look, you can go out and buy the most expensive incident management platforms on the market, and you can write the most detailed runbook templates in the world. But if the underlying culture is broken and punitive, the postmortem process will fail entirely. Fix systems, not people. This is the foundational mantra you absolutely must instill in your engineering teams. If an engineer makes a mistake that brings down a production environment with a single keystroke, the blameless perspective asks a totally different set of questions. It asks, why was it so easy for them to make that mistake in the first place? Why didn't our deployment tooling catch the syntax error? Why didn't the system fail gracefully? See, that is an architectural failure, not a human failure. As platform engineers, our job is to pave roads and build robust guardrails so that humans can innovate safely and confidently. The fundamental reality of modern cloud computing is that while incidents are entirely inevitable, repeated incidents, having the exact same outage twice for the exact same reason, those are completely optional. By truly embracing psychological safety and utilizing highly structured, blameless reviews, you literally transform your worst outages into your greatest engineering assets. Your systems will become far more robust, your teams will become significantly more trusting, and your time to resolution will just drop dramatically. So I'm going to leave you with this final, critical question as you head back to architecting your platforms. When those pagers go off at 3 a.m. and the pressure is on, will your team blame people or will you fix systems? Thank you so much for joining me on this explainer today, and we will see you next time.